Okay, in this video I'm going to be rewriting a trigonometric expression so that it is not in fractional form. We're only working on these two problems on the top here. So we can see here that I have 1 plus 1 over the sine of x, and that's what I want to rewrite. I want to get rid of the fraction and make it so it's all linear, no fractions. The idea here is that we want to multiply both the top and bottom of these fractions by the conjugate of the denominator. And what I mean by that is I want to multiply both top and bottom of this equation by 1 minus sine of x. And the reason for this is going to be clear in a second after I start to work this out. So if I have 1 plus sine x, I want to use 1 minus sine x. Over here it's going to be, if I have 1 minus sine y, I want to use 1 plus the sine of y, and that's what I'm going to multiply by. Okay, so if I multiply these two fractions out, it turns out that I have 1 times 1 minus the sine of x, and I got to distribute, but it's just a 1. So really I end up with 1 minus the sine of x on the top. On the bottom, I have 1 plus the sine of x, 1 minus the sine of x now. And the reason that this is helpful is because now I have a difference of squares on the bottom. You might recognize that as 1 minus sine squared x, right? Now that might seem silly. It's like, okay, how am I getting any closer to not writing this as a fraction? But the nice thing is whenever I see that this is 1 minus sine squared, now all of a sudden that I know, I see sine squared and I automatically think sine squared x plus cosine squared x is equal to 1. So if I rearrange this, if I subtract the sine squared x from both sides, all of a sudden I have left on the right side, on the left side, I have cosine squared of x. Well, you can't see that on the camera, can you? Sine squared plus cosine squared is 1. Subtract sine squared from both sides, and I see that on the left side I have left as a cosine squared. On the right side I have 1 minus sine squared of x, which means I'm going to take then, if cosine squared of x is 1 minus sine squared, I'm going to take this and replace the entire bottom with cosine squared of x. So now I'm left with 1 minus the sine of x over cosine squared of x. Now, because these are both over the same denominator, it really means that I can write them as two separate fractions. I can take this, it's a little messy here in my organization, isn't it? I can write this as 1 minus cosine squared of x minus sine of x over cosine squared of x. And after I do that, I see, okay, I've got 1 over cosine squared. I don't want that to be a fraction. 1 over cosine is secant. That means this is secant squared. Getting closer. I got rid of one of the fractions. Now I need to worry about this. And so I'm like, okay, how can I combine sines and cosines? Well, I got to realize here that cosine squared is really the same thing as cosine times cosine, right? So I'm just going to work with this for a minute. Let's take this. Let's pull it off to the side. Let's pull this off to the side, and let's write this again as sine of x over cosine of x times the cosine of x. And the reason I do that is because the first sine over cosine I see is tangent, right? That's just tangent. And so if I pull those out, if I use those and combine those, that means that I'm left really with 1 over cosine. And I see that that is secant. So with all that in mind, then that means that I can come down here and I can say, you know what, instead of calling that sine over cosine squared, I'm going to call it tangent of x, secant of x. And there I have an expression. It's the exact same thing as 1 over 1 plus the sine of x, and it's not necessarily neater or nicer to use, but there are no fractions, and so that's pretty handy. Let's do it again over here. It's a tough problem, right? Let's do it again over here. Let's hope that it works out a little bit nicer and neater. So I'm going to multiply both the top and the bottom, this time by 1 plus the sine of y, because it's the conjugate. And so if I do this, now I notice that I have a cosine squared that I have to distribute. So I have cosine squared of y plus cosine squared of y sine of y. There's the top. The bottom is 1 minus sine of y, 1 plus the sine of y. And the reason that I want to do this is because this is pretty handy because it gives me a difference of squares on the bottom. So I see here on the top I've got cosine squared y plus cosine squared y sine y. On the bottom I have 1 minus sine squared of y. Now, for the same reasons as the problem that I just did, we can see that 1 minus sine squared is the same thing as cosine squared. So I'm going to rewrite this. In fact, I'm just going to do it to save space. That's the same thing as cosine squared of y. I'm going to replace it right here. And now I've got one denominator, which means I can break this up really into two separate fractions. I've got cosine squared y, the first term on top, plus, and then I've got cosine squared y sine y on the second term. The bottoms of these, the denominator both times, is cosine squared of y. Yeah, this one definitely works out to be nicer and neater because I see over here, those cancel out, I'm left with 1. And over on the right, cosine squareds cancel out, and I end up with sine of y. So in this case, definitely helpful to go ahead and rewrite it as not a fraction because I would rather work with this expression down here than the one on top.